Sorry about that. Okay, so continuing on with chapter 7, I just want to reiterate, like, you do not need to know the exact steps of how to accomplish these different algorithms. So in the book, they're outlined by these green blocks with these pseudocode paragraphs here, but you do not need to know those exact steps. You just need to know to be able to talk about the differences between these algorithms and be able to tell them apart. So moving forward, we've talked about different algorithms that assume that a collection is sorted. So how do you take a set of values in any random order and put them in a specific order that's going to make it more appropriate for your needs, whether that's numeric order, alphabetic order, whatever it is. So we have a couple different sorting algorithms here. The first is called selection sort. Selection sort is very similar to how we as human beings would sort, say, a deck of cards. So if you wanted to put the deck of cards in a specific order, you would typically page through the deck, look for the next card in line, and then place it in a different pile. So if you're looking for ace of hearts, it goes there, two of hearts, three of hearts, and you would typically sort like that. It's a very simplified kind of algorithm. So just stepping through the collection one at a time, find the next item in your list, set it aside. Step through again, find the next item in your list, set it aside. Very, very simple here. The book gives a number of different solutions with increasing complexity, but that's the high level description of what the algorithm's trying to accomplish. So let's see. Bubble sort will step through each element in the array and keep track of what the next smallest element is at each point. So it'll start with the first item and compare it to the second item. Whichever one is smaller, it keeps track of that one, and then compares to the third item. Whichever one's smaller, it keeps track of that one, and on and on. So by the time it gets to the end of the array, it knows somewhere in that array there is an element which is the smallest one. And then it will put it at the beginning. And then it'll step through the next time, and it'll keep track as it goes. Which one is the smallest one at each point? It'll make a comparison and keep track of the next smallest item. And then it'll move it to the second spot in the array, and then everything shifts up. So think of it like bubble sort, like the smallest items are bubbling to the top. So with each pass, you will then first pass, the first item in the array is the smallest item in the array. After the second pass, the second item in the array is the second smallest item in the array, and on and on. So you can think of it as the smallest elements are like bubbling to the top. Insertion sort is you take each item in the array in sequential order and insert that item where it would be in the sorted part of the array. So if you can picture your array as being split up into two parts, the sorted part and the unsorted part. You step through the unsorted part, take the first item, and put it in its appropriate spot in the sorted part of the array. Figure 7.13 on page 226 has a good graphic for how this would work. So if you're stepping through the first time, Phil would be the first name that you find. Phil is an array of 1, so it's automatically sorted. The next item is John. John is alphabetically smaller than Phil, so it would go in the spot ahead of Phil. Step 3, the next name is Al. Al is alphabetically smaller than both John and Phil, so it goes in the front, and on and on. So selection sort, you step through the entire array each time and find the next smallest one, put it in a separate pile. Bubble sort, you step through and make a bunch of comparisons and move it to the beginning of the array each time. And then insertion sort, you take each piece individually and then physically put it in the correct sorted location in the sorted part of the array. Okay, what is next? Let's look at recursion. Okay, so recursion is one of those really kind of goofy topics to try and wrap your head around the first time. The best definition that I've heard for recursion is that if you look up the definition of recursion in the dictionary, it says the definition of recursion is recursion. So basically, recursion just means calling yourself over and over again. The problem with recursion is that you can get stuck in what is called an infinite loop, meaning that you're calling yourself over and over and over again and have no way of stopping. So in order to have a successful recursive algorithm, you need to have what's called a base case, which means some sort of way of indicating that the execution should end, and then you can continue with the rest of your program. Recursion can be very helpful in situations that you would otherwise solve with a loop. It's kind of a subtle distinction between when you would use recursion, where it would be very effective, and where you would use a loop. But that's more for more involved programming projects than we would ever get into in this class. So for the purposes of our work, make sure that you know the definition of recursion. And then there are two specific algorithms that use recursion. We have the recursive binary search, which is the exact same as binary search that we talked about before, but instead of using a loop, now we would then have a function called binary search, which then calls itself. So I'm not going to make you explain that function to me, but at least now you know wherever you have a loop, you could also conceivably use recursion. Now, there is a function called quicksort, which does use recursion specifically, and utilizes this sort of systemic breakdown to take an entire array, break it down into a bunch of subsequent little halves, and then bubble that back up and use the results of those smaller comparisons to then sort the entire array as a whole. So if you wanted to look at page 232 and 233, there are some figures on how that works. And again, I'm not going to ask you to know the steps. I'm just expecting you to know quicksort uses recursion, and it gets your sorts your array. There are a few situations in programming nowadays where it is very helpful for you to do your own sorting, but there are also a fair number of scenarios where it is just easy and effective to use resource libraries or existing solutions to just sort your data for you. But at least you know, if you ever had to write your own programs, that these are the different kinds of algorithms that you might want to use. Finally, the nature of information hiding and abstraction. Computer science is very reliant on the appropriate use of what we call the division of labor. So if you have a gigantic code block that does 10,000 things, it gets very difficult to manage because you're not quite sure what tasks are being done where, what code block is responsible for what. So if you are able to divide up responsibility for different subtasks and give those subtasks to different functions or different classes or different objects, whatever the case may be, then it is much easier for you to do testing, debugging, to make sure that your code is concise and effective, and just in general easier to maintain and utilize. So the reason that works is this concept of information hiding and abstraction, because the different pieces, the different modules within your code are able to do their respective duties without knowing about anything else that's going on around them. So this concept of information hiding is basically, you let me worry about what I have to do, and I'll just give you the result when it's done. You don't have to know the exact details of how I do my job. You just need to know that I'm going to do it, and I'm going to give you the right answer. Similarly, with abstraction, then the module that's calling me can treat me as just some sort of black box. We don't have to worry about how this task is getting done. It just works for us. So in the same way, I'm not very mechanically minded, but I abstract the use of my car every day. I don't need to know how the spark plugs work or how the pistons fire or anything like that. All I need to know is when I push on the pedal, the car goes forward. I know how the gear shift works. So it's this idea of knowing the correct level of detail to make available between the different pieces of your code, so that each piece can just focus on a specific job and then return the result. So it's very, very effective for proper programming and life in general. Okay, so that's chapter 7, and oh yes, and data abstraction and procedural abstraction. So the difference between how data is stored versus how it's used, and then procedural abstraction is the logical view, like the inputs and outputs of an action versus how it's actually implemented. So data abstraction, procedural abstraction. And then control abstraction is like while and if statements. So you don't need to know how an if statement is implemented inside your computer. You just need to know that it's going to do the logical actions that you need it to do when you write your own code. Okay, chapter 7. Very good.